Hello and welcome back. This is the 10th in the R-Instat series on climatic analysis. We use the data from Ghana again. To analyse the data, you need objectives. The example here is from a project called PICSA. PICSA includes the sharing of graphs of the historical climate information with farmers. Our objective is to produce examples of the graphs needed for PICSA. Staff from the Met Service then share these results with agricultural extension or NGO staff who already work with groups of farmers. In PICSA, they in turn discuss and use the graphs with their groups of farmers. From the daily data, these objectives, and many others, lead to a two-step process. The first step is a summary of the daily data, and the second is an analysis of the resulting summaries. The main summary dialogue is here. The start of the season is from about April, so the first demand is for a graph of the 3-month rainfall totals from April to June. We need a summary at the annual level, which is already set. It is a summary of the rainfall, which is selected. The default is the whole year, but our requirement is for April to June. So we use the day range subdialog to select the 3 months that we want. Return to the main menu. We can now see that our day range is set from the 92nd day of the year to the 182nd day of the year. In other words, April to June. Next, we need to specify which summaries to produce. We keep n non-missing, but we uncheck n total, as we know this is 91 days. Keep sum, return, and press OK. This summary step has produced a new data frame. Each row is now a year. For example, the 3-month total at Salt Pond in 1944 was 351 millimetres. There are 146 rows because each of our 2 stations has 73 years of data. Now the second step. Use the PICSA rainfall graph dialog. Plot the annual summaries, and we use the PICSA option to set lines to means and add labels. Return and click OK. Let's look at these graphs in the R viewer. Farmers have usually not seen graphs like this before and appreciated seeing the information for many years together. In this example, perhaps previously they had noticed the recent low years in Tamale and felt it indicated climate change. Now they see that the main message in the rainfall is of a problem of variability rather than change. This contrasts with temperature graphs that usually show an upward trend. The R-Instat tutorial video gave an example of temperatures. Often, an initial result leads to further questions. In this case, there was a demand for a similar graph for the next months, as in July to September. This was partly to see whether this would also show a similar pattern for the last years in Tamale. This can be quickly produced, but we must first rename the summary variable so that it doesn't get overwritten. We call it sum AJ. Then we return to the climatic summary dialog, and we change the day range to July to September. Then we run it again. Next, we open the PICSA rainfall graph dialog and simply press OK. The pattern is different to the April to June totals. The last 4 years in Tamale are no longer so low, and at Salt Pond, these months are between the 2 seasons, and hence the totals are much lower. Some of the other dialogues in R-Instat also produce annual summaries. We assume that a start of the rains graph was also required for Pixar. This is another option in the climatic prepare menu. Together with the end of the rains, spell lengths and extremes. The dialog again fills automatically, assuming you're in the correct data frame, which I'm not. I change it to the correct daily data frame. Now it fills correctly. I need to change my day range so that the earliest date is April 1st and the latest is June 30th. The assumed definition was the first occasion with more than 20 millimeters in 3 days, so change the 2 to 3. We choose to show the date and press OK. The new variables add to those already in the yearly data frame. The summary shows that in Salt Pond in 1944, the rains started on the 146th day of the year, which was May 25th. We return to the Pixar graph dialog, and from there we use our new variable to create a new graph. This is not yet a good result, given the objective. If farmers were to see this graph, they would have to interpret the day numbers in the year. Some work is needed to make this more of a presentation graph. Return to the dialog and press the Pixar Options button. Now we go to the Y-axis. We untick the lower limit and select Date. Return and OK. We could do more, but that's already better. Our next videos look in more detail at this two-step process for rainfall and for temperature data.